Okay, let's say we have a diverging, also known as a concave lens like this one here. And I point at some object, in this case, this person here. Where will the image be formed? Will it be upright and magnified on the right hand side? Will it be inverted and diminished on the right hand side? Or is it going to be a virtual image on the left hand side like this? We're going to represent all objects as an arrow like so, and we're going to see the image that's being formed using a ray diagram. A couple other features of the ray diagram you know is the principal axis, which is a line that goes through the center like this. And then you've got the principal focus, also known as a focal point on either sides because it's a symmetrical lens. And then you've got the focal length as well, which is the distance from the focal point to the center of the lens. Okay, so I'm going to represent this diverging lens using this symbol. Okay, this symbol means either concave or diverging lens. Let's get started with this. Let's make some space. Here's a checklist of things I need to do to make the image. So first of all, a ray that goes through the center of the lens undeflected like this. So it goes from the top of the object through the center undeflected. The second one is a ray that goes parallel to the axis like so until it hits the lens. And now if this was a convex lens or a converging lens, it would be going through the focal point on the right, but now this is actually a diverging lens. So it's going to diverge and move away from the focal point on the left. So you get a ruler, line up like this from where it hits the lens, where the parallel ray is hitting the lens to the focal point on the left, and you draw a dotted line. This is just a construction line, that's not an actual ray of light that's going there. And then you continue with the solid line like this. Okay, let me do that again. So draw a ray parallel to the axis like this. Then use your ruler to see where you're going to diverge away from the focal point on the left. Okay, and then use a solid line once you're actually drawing the ray. Okay, so where these lines meet, it's actually not a real ray that's going through it, this point there. So we know it's going to be a virtual image because the rays aren't actually meeting at that point. That's where the image is formed. So that's your image there. Okay, then don't forget to add arrows for the actual real rays, the solid ones like this. Okay, now time to describe the image. Is it upright or inverted? So as you can see, the arrow is pointing upwards for the image, so it's upright. Is it real or virtual? Well, we're using a dotted line there. That's a construction line. It's not an actual ray that's going through there. So that means the rays aren't actually meeting together. So it's a virtual image. Is it magnified or diminished? As you can see, the image is smaller, so it's diminished. Now, finally, we need to give what factor it's diminished by. So we need to use the equation image size over object size. So let's start counting. Let's count with the object size first. So we had, if I count the number of squares, that's 10 squares for the object. And for the image, I've got 4 squares. So it's going to be 4 divided by 10. So it's times 0.5. That's the magnification factor. Another example here, except the object is a bit closer to the lens. Let's make some space, and here's a checklist of things I need to do. First of all, from the top of the object to the center of the lens undeflected, and then a ray parallel to the axes, and now it's going to diverge away from the focal point on the left because it's a diverging lens. So you use your ruler to join those 2 points with a dotted line, and then you continue that dotted line but using a solid line away from the focal point on the left. Okay, so the image is formed where those lines appear to meet, and that's your virtual image that's going to be formed there. Don't forget to add arrows. Okay, and now time to describe the image. Is it upright or inverted? Clearly it's upright. Is it real or virtual? The rays aren't actually meeting there. One of those is a dotted line there, so it's showing where the ray would appear to come from. So that's a virtual image. Is it magnified or diminished? As you can see, the image is smaller, so it's diminished. By what factor? Let's count the image size and the object size. The object is still 10. The image is around 6, I'd say. So 6 over 10, so times 0.6 is a factor of magnification. So it turns out with a diverging concave lens like these, you always get a virtual image. And it's always going to be upright and diminished. The factor by which it's diminished can change, but that depends on where the object is compared to the lens. Now with a converging and convex lens, you can get both real and virtual images. It can be magnified or diminished, upright or inverted. Yeah. Identify the mistakes a student has made with this ray diagram. Okay, let's check our checklist and just see if the student has done this right. The first ray should be going from the top of the object through the center of the lens. It should be going through this point. As you can see, the student has mistakenly drawn the first ray going through the focal point on the right. So that's wrong. It should be going through the center of the lens like this, undeflected. Okay, what about the second ray? The second ray should be going parallel, like they've correctly drawn, but then it should be going away from the focal point on the left. Now the student has drawn it going away from the bottom of the image when it should be going away from the focal point. So you should get a ruler out and actually draw the dotted line like this, okay, and then it should be going away like that, because this will have an impact on the where the image is formed. Okay, and that's about it. I think all the mistakes, rest are correct.